everyone, and welcome to my virtual laboratory. So today we're going to learn physics and its branches. Let's go! Did you ever wonder why a balloon rises up when you put it on a blow dryer plug in and on? Or is it possible to go into a different dimension like what Barry Allen and Cisco do in the television series of The Flash? So please watch this video as we discover the physics behind it. Physics is the science of energy and matter and how they relate to each other. Physics is divided into two main branches, classical physics and modern physics. Classical physics refers to the traditional topics in physics that were recognized and developed before the beginning of the 20th century. Modern physics, on the other hand, refers to the concepts in physics that have surfaced since the beginning of the 20th century. This branch is mostly concerned with the behavior of matter and energy under extreme conditions, the very large or the very small. Classical physics has sub-branches. Number one is the mechanics. Mechanics is the study of forces acting on bodies, whether at rest or in motion. Statics on forces acting on bodies at rest or stationary objects. Kinematics, the study that deals with the description of motion. Acoustics is the study of the production and propagation of sound waves. Optics is the branch of physics that deals with the study of light. In physics, physical optics or wave optics is the branch of optics that studies interference, diffraction, polarization, and other phenomena for which ray approximation of geometric optics is not valid. Physiological optics is concerned with the perceptual processes in the eye and its associated neuronal structures in the brain. Geometric optics refers on the reflection and refraction of light as encountered in the study of mirrors and lenses. Thermodynamics is the study of the relationship between heat and other forms of energy. In particular, it describes how thermal energy is converted to and from other forms of energy and how it affects matter. Electromagnetism is the study of the properties of electric current and magnetism and their relationship. Electromagnetism is a branch of physics that deals with the electromagnetic force that occurs between electrically charged particles. Electrostatics, as the name implies, is the study of stationary electric charges. Electrodynamics is the branch of physics which deals with rapidly changing electric and magnetic fields. Magnetostatic is the study of the magnetic field produced by steadily moving electric charges. Atomic and nuclear physics are not the same. The term atomic physics is often associated with nuclear power due to the synonymous use of atomic and nuclear in standard English. However, physicists distinguish between atomic and nuclear physics. The atomic physics deals with the atom as a system consisting of a nucleus and electrons. The nuclear physics deals with the nucleus as a system consisting of nucleons, such as protons and neutrons. Main difference is in the scale. What is quantum physics? Put simply, it's the physics that explains how everything works. The best description we have of the nature of the particles that make up matter and the forces with which they interact. Quantum physics underlies how atoms work and so why chemistry and biology work as they do. You, me, and the gatepost, at some level at least, we're all dancing to the quantum tune. If you want to explain how electrons move through a computer chip, how protons of light get turned to electrical current in a solar panel or amplify themselves in a laser, or even just how the sun keeps burning, you'll need to use quantum physics. Einstein's theory of relativity provided a new framework for the old ideas about force, motion, and gravitation. In creating this special theory, he made two assumptions about the universe. The first assumption is that the laws of physics are the same in all inertial frames of reference. This follows from the absence of a universal frame of reference. The assumption states that the same laws of force and motion hold true in different frames of reference. For example, if you're in a bus moving at constant speed and you throw a ball up, it will simply fall down on your lap. But an observer outside the bus, say on the street across the moving bus, will observe the ball as a projectile which was thrown at an angle from the horizontal. The second assumption is based on the result of many experiments. The speed of light, 3 times 10 to the 8 meter per second, in free space has the same value in all inertial frames of reference. The general theory of relativity states that the laws of physics are the same in all frames of reference. Solid-state physics is the study of all properties of solid materials, including electrical conduction in crystals, of semiconductors and metals, superconductivity, and photoconductivity. It has also direct applications, for example, in the technology of transistors and semiconductors. Condensed matter physics is the study of the properties of condensed materials such as solid, liquid, and those intermediate between them and dense gas. Plasma physics is the study of the fourth state of matter, which is plasma. Low temperature physics is also known as cryogenics, from the Greek meaning producing cold. Low temperatures are achieved by removing energy from a substance. The simplest way to cool a substance is to bring it into contact with another substance that is already at low temperature.